head is pounding. I have a huge headache. I think I'll take an aspirin. Hey, do you know where aspirin comes from? It comes from the bark of a weeping willow tree. Hippocrates, who is considered the father of modern medicine, was the first to discover its pain-relieving properties somewhere between 460 and 377 BC. That was like forever ago. Chemists knew there was some compound in the bark that worked wonders, but there were also hundreds of other compounds present too. How did scientists know which compound was the miracle drug? And how did chemists get that compound from a tree in the woods to this pill here? Well, first, all the different compounds in the tree bark had to be separated and tested by someone to figure out which one was the pain reliever. Not it. Sounds tedious. Finding out the identity of unknown substances is a big part of what chemists do. One tool a chemist might use is the empirical formula. The empirical formula is the simplest formula for a compound. It is the smallest whole number ratio of the atoms present. Before scientists know the molecular formula of a compound, they might only have enough data to determine the ratio of atoms present. This is one of the first steps in investigating and identifying unknowns. The empirical formula is different than the molecular formula. The molecular formula is a formula of a compound in which the subscripts give the actual number of each element in the formula. Let's look at the difference between empirical and molecular formulas. Here we have 4 covalent compounds: water, acetic acid, formaldehyde, and glucose. Each has different chemical properties and molecular formulas, but the same or similar empirical formulas. You wouldn't want to drink formaldehyde or acetic acid, but water is of course okay. And as you know, glucose is an important player in cellular respiration. It is also very different from the other 3 compounds. That's why at first it might seem like the empirical formula isn't very useful. More information can be obtained by looking at the molecular formula. The empirical formula doesn't tell the whole story, but it's a good starting point when identifying unknown compounds. You may have heard of this simple poem to find the empirical formula. Percent to mass, mass to mole, divide by small, multiply till whole. I know, it's kind of cheesy, but it's stuck in my head and I just can't get it out. That might be why my head hurts so much. Anyway, let's look at this quick problem. A sample believed to be aspirin contains 60.87% carbon, 4.38% hydrogen, and 34.75% oxygen by mass. What is the empirical formula? The first step was percent to mass. Let's assume we're dealing with a 100-gram sample. That makes converting percent to mass fairly easy. Here's what we've got so far. 60.87% carbon would equal 60.87 grams, 4.38% hydrogen would equal 4.38 grams. 34.75% oxygen would equal 34.75 grams. Now for step 2, mass to mole. Use the molar mass on the PT to convert grams to moles. The molar mass of carbon is 12.01. So if we use dimensional analysis to convert the 60.87 grams of carbon in our sample to moles, we get 5.068 moles of carbon. Next, let's convert the 4.38 grams of hydrogen to moles. The molar mass of hydrogen is 1.01. So there are 4.34 moles of hydrogen in the sample. Finally, let's convert the 34.75 grams of oxygen to moles. If we look at our periodic table, we see the molar mass of oxygen is 15.99 grams. So we have 2.173 moles of oxygen. Phew! Step 3, divide by small. What's that mean? Here, you look at the moles of each element present and find the smallest amount. Oxygen has fewer moles than hydrogen and carbon, so divide all the values by this little guy, 2.173. Here's what the math would look like. Cool, almost done. The last step says multiply until whole. That means multiply these numbers until the values are pretty close to whole numbers. Check out carbon. There are 2.33 moles. I know I've got to multiply by 3 to get 3/10 of a mole into a whole number. Let's try multiplying the rest by 3 to see if we get a whole number. The numbers we just solved for represent the subscripts in a chemical formula. So aspirin is C7H6O3. So like I said earlier, often the chemical formula of a compound is not known. Chemists must determine the percent composition and molar mass of an unknown compound through experimentation. Determining the chemical formula is an important step in understanding the properties of the compound and developing a way to synthesize it in a laboratory. So do you think all aspirin comes from the bark of a willow tree, even today? Well, it took German scientists 1.5 kilograms of willow tree bark just to extract 30 grams of aspirin. I don't think we'd have any willow trees left if we used the same method today. Drugs like aspirin start in little labs, kind of like your chemistry classroom, and some make it into production like aspirin did in the picture here. So that's a big part of what chemists do. They find really cool compounds in nature and extract them from plants, trees, animals, whatever, and figure out how to make them in little labs. Hey, my headache is gone. All right, until next time, this is Lisa D.